Hello, dear student. Myself, Dr. Surekha Jaiswal, Head Department of Physics, Moreshwar College, Bhokardan, District, Jalna. Today we will see mechanics properties of matter and sound. Now, course code number PHY 101. Today's topic is surface tension. Now, see, contents are introduction, example of surface tension, pressure difference across liquid surface. Now, we know if a sewing needle is placed carefully on a water surface, it makes a small depression on the surface and rests there without sinking. Next, we also know the needle does not sink though its density is higher than that of water. Now, in another case, if a glass tube with a small bore, that is capillary tube, is dipped in water, the water rises in the capillary tube and the level of water inside the capillary tube is higher than the level of water outside it. Also, interesting examples of why some insect like water spider floats over water, why we use detergent to clean our clothes, why water rises upward in capillary tube, why mosquito larva floats over water surface but its oil is spread over water, then larva gets sink into water. Also in case of raindrop, why small raindrops are spherical, why mercury is not attached with inner surface of thermometer. While cooking, we add a small amount of vegetable oil to avoid overboiling of water. Also, why some pulses are difficult to cook in hard water. See here. Now we see definition of surface tension. Molecules on liquid surface experience a stretching force normal to its surface is called as surface tension, or the force per unit length acting normally along a line tangent to its free surface of liquid is called surface tension, or it is defined as a tensile force acting on the surface of a liquid in contact with air or between two immiscible liquids. Surface tension is denoted by sigma and its unit is Newton per meter. Molecules of liquid are free to move inside liquid. These molecules are attracting each other due to cohesive force. What is cohesive force? Force of attraction between molecules of same substance is called cohesive force, while that of molecule of different substance is called adhesive force. There are two types of forces, cohesive force and adhesive force. So, force of attraction between molecules of same substance is called the cohesive force, and molecules of different substance is called adhesive force. Molecular force are reflecting when distance between them is about 10 raised to minus 7 meter. The molecular forces obey inverse 8 of power law. The maximum distance at which molecule can attract each other is called molecular range of attraction. This range is spherical in nature, called sphere of influence of molecule. If a molecule is present completely inside liquid, then it's attracted equally from all neighboring molecules, so net attractive force on it is 0. If molecule is present on surface, then it experiences more attractive force inside the surface of liquid than outside. If molecule is just below the surface, then it experiences downward attractive force because more number of molecules are present at downward side than upward side. Molecule present exactly on surface experience downward force and behave like stretched membrane called as surface tension. If an interior molecule is pulled to the surface of liquid, then work has to be done against the downward coercive force and result is increase in potential energy. Since potential energy tends to become minimum and the surface layer tends to contract so as to contain minimum number of molecules in it and tends to have least possible area, and the potential energy per unit of area of the surface is called its surface energy. Now see explanation of surface tension. Now see in figure. Consider a molecule A of liquid lying well within the surface of a liquid. That molecule A is lying inside the surface of a liquid. Now this molecule of water will be pulled in all its directions, see in figure, in all directions, that is shown by this arrow, by the other molecule, that is all the other molecule which are surrounding this molecule will try to pull this molecule towards their own direction. So the resultant of this will be that this molecule would be stationary. It would remain at its position, that is the resultant force acting over this molecule is 0. Now in case, consider a molecule B on the surface of liquid. This molecule experiences force of attraction only due to the molecule lying in the lower half. See, in case of B, lower half of the sphere of influence of the molecule B. The resultant of all these forces is in downward direction, and due to this, the net inward force on the molecules lying on the surface of the liquid, the surface is stretched. Therefore, the free surface of a liquid at rest behave like a stretched membrane. The force which are acting there would be trying to pull the molecule in the downward direction towards the water. Because of that, there would be resultant downward force. Now in case of molecule B, force acting parallel to surface, and similarly force because of the parallel force, surface appears to be stretched, and when this surface is stretched, that is, there is some tensile force which is acting. Now see example of surface tension. First, take a metal ring, dip it in soap solution. Place a moistened loop of cotton thread over the film. The loop has an irregular shape. In case of here, see, this loop is here having the irregular shape, at a loop of cotton thread. So, touch the soap film within the loop with a hot needle. The thread takes a circular shape, seen figure. Now, every point on the thread experiences a force radially outward and parallel to the film. Place a pin or swing needle gently on the surface of water, it floats. There is diffraction on the surface of water and the surface behave like a stretch membrane. Press the needle with the finger, the layer due to surface tension break and the needle sink in water. Also in case of take a shaving brush, dip it in water, take the brush out and the hairs of the brush cleaning together due to the thin layer of water. Also example, that is, take a mixture of spirit and water such that the density of the mixture is equal to the density of olive oil. Now, with the help of a pipette, leave a drop of olive oil inside the mixture of spirit and water. The olive oil drop assumes a spherical shape, seen figure. That is a mixture of spirit and water, and that is drop of olive oil. Now, due to surface tension, the tendency of a fluid or liquid surface is to keep its area minimum for a given volume. For a given volume, the surface area of a sphere is minimum. And another example, that is, falling raindrops are spherical in shape due to surface tension. Next, that is, the lead shot are manufactured in factories based on the property of surface tension. Molten lead is allowed to fall through the end of narrow tube, and the lead drops assume spherical shape due to surface tension. Also, mosquitoes breed on the surface of free water. The layer of water due to surface tension support them. Oil has lesser tension than water. When a drop of oil is sprayed on the surface of water, due to higher surface tension of water, the oil is stretched in all directions as a thin film, and the surface tension of oil surface is small and mosquitoes cannot be breed on it, and therefore to prevent the breeding of mosquito in rainy season, oil is sprayed on the surface of water in pools and ponds. Now, pressure difference across a liquid surface. Molecules near the surface of liquid are pulled downward due to cohesive force, and this downward force acting per unit area of a liquid surface is called cohesive pressure. See in case first, if free surface of a liquid is a plane, then total force due to surface tension on surface molecule is 0 and cohesive pressure inside the liquid is negligibly small. See in figure. Here the surface of liquid is plane. Now here in case of total force due to surface tension on the surface molecule is 0 and cohesive pressure inside the liquid is negligibly small. Now in case of second, if the free surface of liquid is concave, see here in figure B, in nature, then resultant force on a surface molecule would be directed upward. See, this resultant force is directed upward. It means cohesive pressure inside the liquid decreases, and this upward force due to surface tension is counterbalanced by downward pressure. See here in figure. For example, water placed in small capillary form concave shape in case of figure B. Now in case number 3, that is for free convex surface, see in figure C of liquid, the resultant force due to surface tension on a surface molecule acts inward. Here this resultant force acts inward into the liquid and cohesive pressure inside the liquid is increased, and here the downward force due to the surface tension is counterbalanced by pressure in upward direction. For example, if liquid like mercury is placed in a small capillary, then its upper surface is convex in nature. See in figure C. The counterbalance pressure in both above cases is called excess pressure because it is produced due to the effect of surface tension and different than atmospheric pressure on the film, and the excess pressure keeps liquid surface convex or concave at equilibrium position. Excess pressure is always greater in concave side of surface. If drop of liquid is very small, then its shape is spherical. Such a drop has only one free spherical surface. A soap bubble has spherical shape but having two spherical surfaces, one on outside and other on inside, like a hollow ball. Hence soap bubble requires twice excess pressure as compared to identical drop of the same liquid. Thank you.